Hello, my name is Peter Shang. I'm here to tell you a little bit about what we have been doing on the prediction of future coastal flooding risk and the role of coastal wetland for reducing flood damage in Southwest Florida in a changing climate. I would like to thank my co-authors from UF, FGCU, USGS, South Florida Water Management District, Rookery Bay Near, and Flow 2D. In particular, Mike Severese, who's working on the ground every day with the stakeholders, including Collier County, Naples, Marco Island, Rookery Bay Near, South Florida Water Management District, and 10,000 Island National Wildlife Refuge. I also like to thank NOAA Restore Sciene Program and ESLR Program for their support. We use a three-dimensional vegetation-resolving surge wave model to simulate the probabilistic flood maps in Southwest Florida during current climate 2030, 2060, and 2100. For each of these 20-year periods, we simulate the flood during 300 plus optimal storms determined by the JPMOS statistical method. From these results, we can determine the flood over the large coastal floodplain with any desired return period, such as 100 or 500 years. Tropical cyclones are predicted to become more intense in Southwest Florida in the remainder of the 21st century, according to most climate models. These more intense storms will increase storm surge and wave and property damage in the future. Sea level rise is accelerating. Here we show the NOAA prediction for global mean sea level and regional sea level at Naples. These rising sea levels with more intense storms will significantly increase the future flood risk in Southwest Florida. As the sea level rises, coastal wetland will change significantly as time goes on. As you can see here, according to the simulation of an elevation-based wetland response model to sea level rise by USGS, some of the mangrove along the coast is turned into open water, and some of the marsh upland is converted by the migrating mangrove. As an example, we show the 1% flood maps during current climate 2030 and 2060. The current climate map on the left side compares quite well with the FEMA flood map. However, FEMA does not have future flood maps. As you can see, with more intense storm and sea level rise, flood hazard in 2030 is higher than the current climate, and by 2060, the flood hazard is almost doubled from the current value. During Hurricane Irma, our model simulation showed Collier County incurred about $68 million in flood loss, which compares quite well with the FEMA NFIP payout of $50 million. If the wetlands were removed, as you see on the right, flood loss would increase by $13 million according to our simulation. In a 1% flood event, mangrove would reduce about $40 million damage from the $100 million potential flood damage, resulting in 40% saving. As part of the project, we have created an ACUNE Geo Tool, which consists of the following products: 1% flood maps, asset maps, annualized damage maps, nuisance flood maps, and bathtub flood maps, vegetation maps for current climate 2030, 2060, and 2100. This ACUNE Geo Tool is being used by the stakeholders for resilience planning as well as wetland restoration planning. With the ACUNE Plus project funded by NOAA ESLR Program, we are integrating programs, projects, and products by coupling 4 different models, including the coastal model, the watershed model, urban stormwater model, and the process-based mangrove model. Using these coupled models, we will be improving the coastal flood maps and also allow stakeholders to develop mangrove restoration plans. Due largely to the effort of Mike Savarese, my partner on this project, we were able to obtain the very detailed asset maps of numerous infrastructures in Southwest Florida. These infrastructure maps are provided by stakeholders including Collier County, City of Naples and Marco Island, South Florida Water Management District, Rookery Bay Near, 10,000 Island National Wildlife Refuge, and National Park Service. Led by Mike Savarese and Jessica McIntosh, a large group of stakeholders have identified 3 categories of potential wetland restoration projects, including natural systems, blended natural and urban system, as well as some radical ideas. We are currently considering using our integrated modeling system to assess the feasibility of the following potential wetland restoration projects. For example, increasing hydrologic conductivity under the East Trail, assessing the value of Clam Bay mangroves for flood protection, assessing the value of island loss or gain in the Cape Romano complex on the resiliency of Marco Island. We are considering simulation of turning sections of Highway 41 into bridges to increase hydrologic connectivity to restore mangroves to the south of 41. This concludes my talk. Questions, please.